More questions related to topic moles, empirical formula, and percentage. So in the first question, sulfur dioxide react with chlorine in addition reaction to form a sulfuryl chloride. 8 grams of sulfur dioxide was mixed with 14.2 grams of chlorine. The mass of 1 mole of SO2 and Cl2 is 135 grams. Calculate the mass of sulfuryl chloride formed by this mixture. So first we need the moles of sulfur dioxide. How to get the moles of sulfur dioxide? Which formula we'll use if we know the mass of sulfur dioxide? So moles is equals to mass in gram over molar mass. This is a formula which we will use, and the mass in gram for sulfur dioxide is given 8. And about the molar mass of sulfur dioxide, how to get the molar mass of sulfur dioxide? Sulfur is 32 plus oxygen is 16 multiplied by 2. So 32 plus 32, that is equals to 64. So 8 divided by 64, how many moles will get? 0.125. Then calculate the number of moles of chlorine in the mixture. Like it is mixed with 14.2 grams of chlorine. So how to get the mole? The same formula, moles is equals to mass in gram over molar mass. The mass in gram of chlorine is given, which is 14.2. But what about the molar mass? So the same way we'll find the molar mass of chlorine. Because it is Cl2, so chlorine is 35.5. Its atomic mass of chlorine, average atomic mass of the two isotopes of chlorine, multiplied by 2, so that is 71. So 14.2 divided by 71, what's the answer? 0.2. So we have 0.2 moles of chlorine. Now the next part, which reagent is in excess? Which reagent is more than enough? So how we'll know? Look, the simple ratio between sulfur dioxide and chlorine is 1:1. Like 1 mole of sulfur dioxide mixed with 1 mole of chlorine. According to the ratio, that is 1:1. So if we have like 0.125 grams of 0.125 moles of sulfur dioxide, how many moles of chlorine are needed? For a complete reaction we need 0.125, but we have zero point 0.2, we have more chlorine than what we need. So which reagent is in excess and which reagent is a limiting? They're asking which reagent is not in excess. So which one is not in excess, sulfur dioxide or chlorine? Not in excess means the limiting reagent. So sulfur dioxide is not in excess or sulfur dioxide is a limiting. And whenever you're finding, so sulfur dioxide is limiting where excess is chlorine is excess. In the first part, they give 8 grams of sulfur dioxide. So how many moles are there in 8 gram of sulfur dioxide? The formula is moles equal mass in gram divided by molar mass. The mass in gram of sulfur dioxide is 8. Molar mass of sulfur dioxide is 64. So we'll get 0.125. Then moles of chlorine in the mixture, again moles equal mass in gram over molar mass. Mass in gram is 14.2 and the molar mass, which is 35.5 multiplied by 2, that is 71. So molar mass of chlorine is 71. When we divide, we'll get the moles. Now they're asking which reagent is not in excess. Not in excess means they're asking for limiting reagent. So how to find a limiting reagent? As you can see, the ratio between sulfur dioxide and chlorine is 1:1. Means 1 mole of sulfur dioxide required 1 moles of chlorine. So if we have 0.125 moles of sulfur dioxide, how many moles are needed for a complete reaction? We need only 0.125. This is what we need for a complete reaction. But we have 0.2 moles of chlorine, we have more than what we need for a complete reaction. That's why in this one, sulfur dioxide is a limiting reagent and chlorine is in excess. But they're asking which one is not in excess or which one is a limiting reagent. So sulfur dioxide. Then how many moles of sulfur dioxide are formed? So whenever you're finding the amount of a product, you always take a limiting reagent. So sulfur dioxide is a limiting reagent. We'll take a ratio between sulfur dioxide and sulfuryl chloride. So the ratio between them 1 is to 1. So if we have how many moles of sulfur dioxide are there? 0.125. So how many moles of sulfuryl chloride will be there? It will also be 0.125. And then calculate the mass in gram. The mass of 1 mole or molar mass is 135. So how to get the mass in gram? The formula is moles equal mass in gram over molar mass, or we can say mass in gram is equals to moles multiplied by molar mass. So in the question, the moles are 0.125 and the molar mass is 135. So when we multiply them, we'll get 16.87 grams, 875 grams. Is it clear, discussion? How we work out the mass of, whenever two reactants both are given, so you always use a limiting reagent or a limiting reactant to find the product, because if you use an access reagent then you will get a wrong answer, as the access reagent is the one which is more than enough for a complete reaction, or it will not be completely used up. That's why if you use an access reagent your answer will be wrong. Another question: iron 3 sulfate decomposes when heated. Calculate the mass of iron 3 oxide formed and the volume of sulfur trioxide produced when 10 grams of iron 3 sulfate was heated. The mass of 1 mole or molar mass is 400 for iron sulfate. Calculate the number of moles of iron sulfate. So how to get the moles of iron sulfate? We have the mass of iron 3 sulfate. So the formula, again we'll use the same formula, moles equal mass in gram over molar mass. So the mass in gram was 10 and divided by the molar mass, which is given 400. So 10 divided by 400, that is equals to 0.025. Then the number of moles of iron oxide formed. In the question, nothing is given related to iron oxide. So what we will use? We'll use a ratio for the second part. And what ratio we will use? Because we have iron sulfate and we need iron oxide. So ratio between iron sulfate and iron oxide is 1 is to 1. So when the ratio is 1 is to 1, you don't have to even um, just go on or show that it is 1 is to 1. You can just directly write the answer here. If the ratio is 1 is to 1, if I have 0.025 moles of iron sulfate, then X moles of iron oxide. So I'll get the same moles, which is equals to 0.025 moles of iron oxide will be there. Then mass of iron oxide formed in gram. So how to get the mass in gram? We have the formula, mass in gram is equals to moles multiplied by molar mass. So the mass in gram, moles we are having 0.025 multiplied by molar mass of iron oxide. How to find the molar mass of iron oxide? So molar mass of iron oxide, its mass of iron is 56. You can use the periodic table for this. 56 multiplied by 2 plus oxygen is 16 multiplied by 3. So 56 into 2 It will be 112 and 16 multiplied by 3, so that is 48. So total will be 160. So 0.0125 multiplied by 160. What's the answer in grams? So we'll get 4 grams of iron, 3 oxide. The next part, number of moles of sulfur trioxide. Again in the question, nothing is given related to sulfur trioxide. So again, what we will use? We will use a ratio. And again, we will use the ratio of iron sulfate, because in the beginning we have iron sulfate. So we'll take a ratio between, this time we'll take a ratio between iron sulfate and sulfur trioxide. Now the ratio for 3 sulfate and sulfur trioxide is 1 is to 3. So if 1 is to 3 and we have 0.025 moles of iron 3 sulfate, then X moles will be there. So sulfur trioxide moles will be 3 times. So this will be 0.075 moles will be there for sulfur trioxide. And then for sulfur trioxide, we need a volume. So how to get a volume from the mole? So volume of a gas is equals to volume in dm cube for a gas is equals to moles multiplied by molar volume, which is 24. So 0.075 multiplied by 24. What's the final answer? So 1.8 decimeter cube. Is it clear? Discussion which is related to moles, molar volume. So you will find a pattern here. Look what we did. The first we use a formula, then ratio, then formula, then ratio, then formula. Is it clear to everyone? Discussion. Then another, this question is having two parts. One is about the percentage yield, and the first one is about like finding reacted and unreacted moles. So both parts are interrelated. In the first part, an excess of nickel carbonate, like we use more than enough nickel carbonate, which is 12 gram, was added to 40 cm cube and 2 mole per dm cube sulfuric acid. So sulfuric acid is a limiting reagent and nickel carbonate is an excess reagent. Unreacted nickel carbonate was filtered off and filtrate evaporated to obtain the crystals. Mass of 1 mole of hydrated nickel sulfate is 281 and mass of 1 mole of nickel carbonate is 119. Calculate the mass of unreacted nickel carbonate. The number of moles of sulfuric acid in 40 cm cube, 2 mole per dm cube. So they already did the first part for you, that is 0.08. Now they are asking number of moles of nickel carbonate reacted. So how, because this 12 gram, we have the mass of nickel carbonate, but that is in excess, like that is more than enough for a complete reaction. They are asking how many are reacted. So how we'll know how many are reacted? We'll take a ratio. Why we did not use a formula here? Because if I use a formula, I will get the moles, but that is the total moles of nickel carbonate, not the one which is reacted. So this part, to solve this part, I will use a ratio. And what ratio we will take? We will take a ratio between nickel carbonate and sulfuric acid. The ratio between them is 1 is to 1, 0.08 moles of sulfuric acid. Then same number of moles will be there for nickel carbonate, which is equals to 0.08. Then mass of nickel carbonate, these are 0.08 moles of nickel carbonate are the one which is reacted. Mass of nickel carbonate reacted. So to get the mass, we'll use a formula. Mass in gram is equals to moles multiplied by relative molecular mass. So this will be 0.08 multiplied by, they already give you the mass of nickel carbonate, it is 119. What's the answer in grams? 9.52. So 9.52 grams of nickel carbonate is the one which is reacted. Mass of unreacted. What will be the mass of unreacted if 12 gram was the total and out of 12, 9.25 is reacted? So 2.48, and basically this 2.48 is a difference of the total minus the one which is reacted. That will give 2.48 grams which are unreacted. Then the next part, the experiment produced 10.4 grams of hydrated nickel sulfate. So we get this practically, the practical value of hydrated nickel sulfate is 10.4. Practically we are getting this much amount. Calculate the percentage yield, maximum number of moles of nickel sulfate that could be formed. So how we can work out the maximum number of moles of nickel sulfate formed? Yeah, that's right, 0.08, because what happened, sulfuric acid is a limiting reagent. So first what we will do, we'll take a ratio of sulfuric acid to normal nickel sulfate, anhydrous nickel sulfate. So ratio is 1 is to 1. The limiting reagent 0.08 moles were there, so we'll have the same moles of nickel sulfate. And from nickel sulfate to hydrated nickel sulfate, the ratio is also 1 is to 1. So if I take a ratio of nickel sulfate to hydrated nickel sulfate, the ratio is 1 is to 1. So if 0.08, that will be X. So I'll get the same 0.08 moles of hydrated nickel sulfate. So the number of the moles of hydrated nickel sulfate, that is 0.08. Then maximum mass in gram. So if we need a mass in gram, the formula mass in gram is moles multiplied by molar mass. So moles, yeah, to 22.48, moles are 0.08, and the molar mass they already gave you in the question, 281. So when you multiply by 281, you will get 22.48. So theory suggests I should get this amount, but practically we are getting only this. So the percentage yield is a practical value divided by theoretical value into 100. So percentage yield, practically we are getting 10.4, but theoretically we should get 22.45, 48, sorry, and into 100. So when we multiply, what we'll get 46%, 46.3% yield. 46.26 you can write, 46.3 also you can write. So what it shows, like if I need, if I should get 100 grams, practically I'll not get 100 grams, I will only get 46.3 grams. Like if I should get 100 gram of a product, practically I will get only 46.3 grams of product. And why we always have a lower practical value, there are many reasons for that. Maybe the reactants are not pure, maybe the reactants does not completely react, maybe some of the reactant might lost or the product might lost during the stages of obtaining the substance. So there are many reasons for having a lower yield or less than 100%. An ore of a copper is there, which is chalcopyrite, which is mixed with mixed sulfide of iron and copper. Find the empirical formula. Look, the total mass of ore is 13.8. It contains 4.8 grams of copper, 4.2 grams of iron, rest is sulfur. How much will be the sulfur? You can use a screen annotation to answer this part. You can, so it's not necessary you solve on the same. You can use any part of the screen to solve this. So first to get the empirical formula, we'll divide by atomic mass. Atomic mass of copper is 64, iron is 56, sulfur is 32. For I will write the atomic masses here. Copper 64, iron is 56, and sulfur is 32. The second part is find the number of moles of atom. Just divide by their atomic masses, like 4.8 divided by 64, and for iron it will be 4.2 divided by 56. And for sulfur it will be 4.8 divided by 32. Then when you divide by the smallest value 0.075, each number by 0.075, and at the last just mention a formula CuFeNS2, that's right. The meaning of a simplest mole ratio is just take a simple ratio. How to take a ratio between the numbers? If they say simplest mole ratio means it should be in a whole number. So to take a simplest ratio or simplest mole ratio, just divide by smallest value to get the simplest ratio, and it should be in a whole number. And the correct answer is CuFeS2, that's right. So when we divide these, we have these numbers, the moles. But when we say simplest mole ratio means it should be in a whole number. When we divide by the smallest value, so we'll get them in whole number. Why 0.15 is equals to 2? Because what happened, basically, this was 4.8. Then what we did, we divide this by 64. We divide this by 56. We divide this by 32. When we divide this, this was 0.075, this was 0.075, and this was 0.15. Then to take a simplest mole ratio, we divide by smallest value. So when we divide by smallest value, this will be 1. 0.0575 is the smallest value. This is 1. And 0.075, 1.15 divided by 0.075, that is 2. That's why it is CuFeS2. So when you take a simplest ratio, you divide by the smallest value in the combination. That's how we work out the empirical formula. Okay, in this part, next part, one piece of marble which is 0.3 gram was added to 5 cm cube of hydrochloric acid of concentration 1 mole per dm cube. Which reagent is in excess? And keep in mind the equation will be there when they're asking for reagent excess or limiting. This is the equation. So calcium carbonate and hydrochloric acid, the ratio is 1 is to 2. I'll write this equation here. When calcium carbonate, metal carbonate react with hydrochloric acid, it gives calcium chloride, CaCl2, plus carbon dioxide plus water. Number of moles of calcium carbonate. How to get the moles of calcium carbonate? We have the mass of calcium carbonate, we have the molar mass. So the formula to get the moles equal mass in gram divided by molar mass. So moles equal mass in gram divided by molar mass. So 0.03 divided by 100, so you'll get 0.003. Then number of moles of HCl. For HCl, the volume is given and the concentration. So how to get the moles from volume and concentration of a solution? So moles equal volume in dm cube multiplied by concentration. The volume should be in decimeter cube. So it will be 0.005 multiplied by 1. So you will get the same answer, 0.005 moles. Now they're asking which reagent is in excess. So to know which one is excess or limiting, or 5 exponent minus 3, you can also write. So the ratio between calcium carbonate and hydrochloric acid, the ratio is 1 is to 2. So if I have 0.003 moles of calcium carbonate, I need X moles for a complete reaction. So multiply 0.006 moles of HCl are needed. But how many moles we have? We have 0.005. So we have less than what we need. So it means HCl is a limiting reagent and calcium carbonate is in excess. Or calcium carbonate moles are more than enough. So CaCO3 is in excess. And reason, because it require 0.006 moles of HCl for complete reaction, but we have only 0.005 moles of HCl. So if one is limiting, the other one will be in excess. Then use your answer to part 2, calculate the maximum volume of carbon dioxide. So whenever we are solving a question and finding a product, we always use a limiting reagent. So first, to get the carbon dioxide, what I will use? I will use a limiting reagent. And what is a limiting reagent here? Here HCl is a limiting reagent. So first using HCl, because to get the volume, I should know the moles first. So HCl and carbon dioxide, the ratio is 2 is to 1. So how many moles of HCl we have? We have 0.005. Then multiply X. What will be the value for moles of carbon dioxide? 0.002 0.005 divided by 2, so 0.0025. These are the moles of carbon dioxide, but we need a volume, so we'll multiply by 24. What's the final answer in DMQ? Because it is a gas, for gas to find the volume, its moles multiply by 24. So 0.06 decimeter cube of carbon dioxide gas produced from this reaction, in which we have HCl as a limiting reagent. And normally when we are preparing a salt, we always take acids as a limiting reagent, so that excess of the metal oxide, metal carbonate or metal can be removed from the mixture by filtration. Otherwise, if acid was in excess, it will be difficult to separate the acid from the salt solution. So practically also, we have acid as a limiting reagent when we are trying to prepare a salt from its solution. It is 0.0025, not 1525. When you took the ratio, this will be 0.0025 and then multiply by 24. I was writing 2 here, maybe it. In the next question, 9.12 grams of anhydrous iron 2 sulfate was heated. Calculate the mass of iron 3 oxide and the volume of sulfur trioxide at room temperature and pressure. RTP means room temperature pressure. Mass of 1 mole of iron sulfate is given. Number of moles of iron sulfate used. We have the mass of iron sulfate. We need the moles. So the formula which we will use to get the moles equal mass in gram divided by molar mass. So mass in gram, in the question it is 9.12 and the molar mass it is 152, that's given in the question. So 0.06. Number of moles of iron oxide formed. Regarding the iron oxide, nothing is given, so what we will use? We'll use a ratio here, and we'll take a ratio between iron sulfate, iron 2 sulfate and iron oxide. The ratio between them is 2 is to 1. So if we have 0.06 mole, this will be X. Cross multiply, so you will get 0.03 moles of iron oxide. Mass of 1 mole of iron oxide, iron 3 oxide. So mass of 1 mole means molar mass or molecular mass here. So, because it's a molecule, so molecular mass. So iron is 56. You will use a periodic table for this. Basically, when they ask for mass of 1 mole, it means if it's a molecule, then molecular mass. If it's an atom, then atomic mass. So it will be 56 multiplied by 2, which is 112, and 16 multiplied by 3, that is 48. So 110, 12 plus 48, that is equals to 160. Mass of iron oxide form. So how to get the mass of iron oxide form? When you need the mass in gram, it is moles multiplied by molar mass. So moles in the question 0.03 and the molar mass is given 160. So 0.03 multiplied by 160, that is equals to 4.8 grams of iron 3 oxide. Then number of moles of sulfur trioxide, again in the question nothing is given related to sulfur trioxide. So we will again use the ratio, and we'll take a ratio between iron sulfate and sulfur trioxide. The ratio between iron sulfate and sulfur trioxide is 2 is to 1. So if 0.03 moles were there, 0.06 moles were there for iron sulfate, then X moles for sulfur trioxide. So we'll get the same mole 0.03 as it was for iron oxide. And then to get the volume, the formula for gases, it is moles multiplied by 24 to get the volume of the gas. So 0.03 multiplied by 24, so it is 0.72. Is it clear to everyone? So we'll get 0.72 moles of 0.72 decimeter cube of sulfur trioxide. Solve this one. 3 minutes left. So number of moles of HCl used. So we have 50 cm cube and 2 mole per dm cube. So how to get the number of moles? It's concentration into volume. Concentration is 2 and the volume is 50, so it will be 0.05. When we multiply, it will be 0.1. Then moles of strontium chloride that could be formed. So you need a ratio for this, and the equation is there. The ratio between HCl and strontium chloride is 2:1. So ratio between strontium chloride and HCl in the question is 2:1. 1 mole of strontium chloride react with 2 moles of HCl. So if you have 0.1 moles, then it will be X. Cross multiply, so you'll get 0.05. That is strontium chloride moles, and hydrated strontium chloride will also be same number of moles, because strontium chloride and hydrated strontium chloride, they have the ratio 1:1. Anhydrous and hydrated, the ratio will be same. Mass of 1 mole of strontium chloride is 267. Theoretical yield. So theoretically, how much we'll get, or yield or mass in gram? So moles multiply by molar mass, which is 267. When you multiply, you will get 13.35 gram. So practically you're getting 6.4, but theoretically you're getting 13.35. So the percentage yield is the practical value of a product divided by theoretical value or theoretical yield multiplied by 100. What is the percentage yield here? So you're getting 47%, 47.9. So 47.9%, 47.9% is the yield or the percentage yield. So example, if you should get 100 grams of a product, you will not get 100 grams, you will only get 47.9 grams of what you should get. If the total should be 100, you will only get 47.9 gram of a product. So first we got the moles of HCl. Using a moles of HCl, we find the moles of strontium chloride hydrated, and then we got the mass, and percentage yield is a practical value of a product divided by theoretical value multiplied by 100. Is it clear, this question?